Oh, hello. Welcome back to the continuing lecture in investments. Uh, well, um, after cutting off recording of the last video, I just realized that um, for the last 5 minutes of the lecture, I I forgot to switch the screen. I forgot to switch to PowerPoint. From the Excel file. And I was, just talking for the last 5 minutes without the PowerPoint screen. But, I'm sure you have, we didn't really go deep into this topic. So uh, uh, I'm sure you could pretty much, follow what was going on even without the screen. Um, Let me go back and reiterate what we talked about in the last five for the last 5 minute segment of the last video. Basically, we use annual percentage rate for annualized rate of return, and uh, basically APR is the simple interest rate, right? If you I mean, by annual rate by itself, there's no distinction between simple rate and compound interest rate. But the APR, when we have multiple multiple compoundings per year, right? Um, for example, if you have 4 compoundings per year, which means quarterly compounding, right? And if APR is 6%, each each quarter, what gets compounded is 1.5%. In other words, APR divided by compounding frequency, right? APR divided by compounding frequency. And our compounding frequency symbol for our compounding frequency per year is M. And although in the original PowerPoint it is, expressed as N, but actually, I prefer to use M because M is the M would stand for I would I would I would reason that the reason they I would reason that M stands for multiple periods, multiple, right? Um, M would stand for that. So it represents the compounding frequency per year, right? So if it is quarterly compounding, there are 4 compoundings per year. Each period, each quarter, 1.5% is compounded, which is called a periodic rate. Periodic rate, right? And the reason I don't like N to be compounding frequency per year is because N is usually the symbol for total number of compounding during the holding period. Right? For example, if holding period is 5 years, right? If holding period is 5 years, if compounding frequency per year is 4, right? Quarterly compounding, and over this 5-year holding period, there will be 20 compoundings. And usually N is the symbol reserved for that actual number of compounding or total number of compounding during the holding period, right? So we'll make, some clear distinctions here in the symbols, right? R is the periodic rate. M is the compounding frequency per year, right? N is the total number of compounding during the holding period, right? So, but then think about it. Periodic rate is simply APR divided by M. But we use it for compounding So in other words, even in one single year, right? If it is 1.5%, right? 1.5% is 0.015, right? So think about it. Even in a year, within a year, there will be 4 compoundings of 1.015, right? Raised to 4 going on, right? There are 4 compoundings. Then, obviously, by the end of the year, the actual result won't be greater. Will be greater than 6%. It won't be exactly 6%. Actually, it's going to be something like 6.14%, and you can easily verify that. Okay, and we know what this is called: 6.14%. And this is called effective annual rate or equivalent annual rate, or also called APY, annual percentage yield. So there will be a slight difference in APR and APY because of this compounding. Okay. So our question is, do we use APR or AP? Well, basically, APR is roughly equivalent. APR is exactly equal to a natural log of 1 plus APY. And always APR is the basis, because how did you get to APR? Well, you get to APR, right? Remember, using the taking the geometric average, or dollar weighted average, whichever, depending on the context, right? Usually, most of the times, geometric average. I mean, if holding period is 5 years, right? You take, geometric average, and that geometric average is APR, right? And then we tweak it by, by adjusting to its periodic, tweaking it by its compounding frequency per year, and we get to the periodic rate. So we easily understand, then how to get to effective interest rate. Effective interest rate is actually, 1 plus, R periodic rate raised to M. And of course, just the EAR alone, you must subtract 1. But this is, 1 plus EAR, so you don't have to subtract 1. Then to get to APR, I mean, from APY to get to APR, is simply solving this equation in reverse. Solving this equation for APR, then you would get this. Okay, and you can verify that later. Yeah. Another interesting thing is, another critical point we have to understand here is that in reality, when you are dealing with stocks, right, the growth rate of the stock has to be the continuous growth. The growth has to be continuous growth. Why? Because that's the reality. I mean, stocks don't grow at discrete time. Stocks don't grow by discrete time. In other words, um, stock prices constantly and continuously change. Constantly and continuously change. It's fluctuating. It's in flux, right? Um, it's continuously, changing. And you might say, um, trading is not necessarily happening continuously, but because trading can sometimes, every second, or 5 seconds, the interval between each each transaction is irregular, right? Sometimes there is a pause, long pause, market has, um, hit some, resistance or hit some support, um, uh, the trading halts, right? And it may next trading may happen, in 15 minutes or 30 minutes, right? But, it's irregular. Sometimes, like every second or even every nanosecond, right? Nanosecond. Especially these days, they use, a supercomputer for to do algorithmic trading, and you know, um, supercomputers can make a bet, by uh, 1/100th of a second, ahead, or 1,000th of a second ahead, or I mean, um, so in other words, there is no regularity, in trading, although companies collect and compile data quarterly. So at the end of each quarter, then they compile the data and calculate the quarterly returns, and release that information. But that's when they collect and compile the data and report the data, right? But the actual transaction happens regardless of when the company is collected. I mean, it doesn't matter. Transactions, in the market happens, almost, continuously. So, um, to track the actual, uh, trading, right, and the returns resulting from that continuous trading, we have to use continuous time. And if you use continuous time, in other words, compounding is done continuously, then we know that we have to use, exponential function or Euler's number. This is what we also did in, Finance 100. So I'm not going to go over, the Euler's number again. But, since, future in continuous compounding, future value is, present value or principal times exponential raised to exponential function or Euler's number raised to r times t. So in continuous compounding, right, APY, or the effective annual rate, will be e raised to APR, r, right, -1. And the reason you subtract -1 is just to get the APY, but the gross return, the net return, right? And then APR is then, if you solve this for APR, right, it's natural log of 1 plus effective annual rate, or APY. Okay, and that APR is called, continuously compounded return. Continuously compounded return. just quickly, recap. Um, we know Euler's number and natural log are reverse functions of each other, right? Natural log is basically the log with, e as the base. And so because this base is e, the same thing, right? Natural log of exponential function is 1, simply 1, right? So then, natural log of e raised to r is simply r, because natural log and, Euler's number, exponential function, are, canceling out each other. And I don't want to go back to the, properties of, log, and, we know, is there a space here? We know that log of a, base a, right? Log of a to base a raised to x is x, right? Simply, right? In other words, think about it. If this is, log of, 100 to base 10, which is, log of, 10 squared to base 10. And what is log of 10 to base 10? It is 1, which means, log of 10 to base 10 is 10 to 1, right? 10 to itself. So that exponent is 1. And if it is 2, right, 10 squared, right, then it simply becomes 2, because, when the base and the body of the log, when the base and the body of the log are the same, then and anyway, it's not only because of that. The exponent, this is one of the properties of log. The exponent of the log will be, it can be moved down to the front of the log like it is a product, right? In other words, coefficient of this variable, right? And then since this is just 1, right? Anything with the whole thing is 1, right? Simply becomes the exponent. So because of that property, right? Natural log of e raised to r is simply r, and which is by definition, right, natural log of 1 plus effective annual rate. Okay, so that that is basically continuous, continuously compounded return, and we will use we're not going to use continuous, compounding, or we will use from time to time, but we will still continue with the we'll keep using discrete compounding because it's conceptually easier, and but we should at least be prepared to be, we should be familiarized. You should be familiarized with, exponential function and the natural log and continuous compounding. So based on this, then we can say 1 plus EAR is e raised to r, and EAR alone is e raised to r minus 1, which is, I already put it there. Now, let's do some exercise, Excel exercise of this. So I want to switch to, let's see if this is, okay. Let me switch to, I don't want to make the same mistake as I was the whole time, I didn't, the whole time I was speaking with the material to project. So let me stop sharing this and share. Alrighty, so you must be able to see this just about now. And the file name, you can find it. The file name is BKM Chapter 5 and 6 Exercises 0. Okay. So here I did I put some, continuously compounded return, some exercise to see the connection between continuously compounded return and natural log, right? Now, here, suppose, PT is 1,000 and PT minus 1 is 900. Let me make it, oops, I make this, it will be the same result anyway. Right? So you had a $90 stock, and at time t minus 1, and at time t, it went up to $100. Okay, and if you just divide PT by PT minus 1, then you will get a gross return, which will be this. But if you what is this? If you subtract PT minus 1 from PT, that's capital gains, right? That's capital gains. And then divided by PT minus 1, and then you get only the net return, right? Now, let's take a common log. This is, log to base 10, right? Common log. It's just not saying that, but, log to base 10, common log. How do I know it is common log? Because here, you see, log to base 10 of this, right? And it's going to be 2 because, think about it. Log to base 10, right? 100 is, 10 squared, so it will have to be 2, right? And then log of 90 will be 1.9542. And then, if you take the log of the PT over PT minus 1, the gross return, it will give you exactly also 111%. Now, let me increase the decimal here. We'll see, right? It's the same thing. And if you raise, if you raise 10 to, these exponents, right? In other words, this column is 10 raised to 10 raised to what's in column, what's going on in column E. In other words, D14 minus D15 is, log of, 2, 2 minus, 10 raised to 2 minus 1.94 for 2. So what did I just do? This is actually, slightly, I should have, this was slightly wrong, incorrect, but you get the idea. I did just this, right? If I take, log of this ratio, right? Log of, 100 over, 90, right? It gives you exactly a gross return, right? Which is, 10 raised to this ratio, right? It will give you gross return. And this one, I think what I tried to do was, doing, let me do this. 10 raised to basically, this is the growth rate, right? 10 squared, the growth rate between 10 squared and 10 raised to 1.9542, and the growth rate would be like this. And then let's see how much, how much the difference is, in if you take the natural log. If you take the natural log of 100, right? That's the natural log of 100. The natural log of 90. That's the natural log of 90. If you take the ratio between the two, just like this, right? This is it. And if you take the difference between the two, actually, this is normally, it's either this way or this way. It doesn't, because it's the properties of log. When the base is the same, right? Base of the two logs are the same. Log of x times y to base a can be, broken up into log of x plus log of y, as long as the base is the same. And then the called quotient rule, but in other words, ratio, right? uh, log of x over y to base a, this, then you can break it up into, because it's also, related to uh, the exponent rule, right? Exponent rule, and I'm not going to go, with very, limited time. Uh, this is something that was already covered in, Finance 100. What's important is that using this, and also, this rule, we talked about this. The exponent can be brought down like, like a coefficient, and uh, eventually, if uh, if the base and the this part of the log are the same, you are just left with, I used, common log as an example. So using that rule, and even if it is common log, it would give you the same result. So here, I got this, and I can predict, if I subtract common log of PT minus common log of PT minus 1, I will get the same result here. Now, what about the if I take the continuously compounded return, right? Actually, just percentage. See, if I raise it to, if I raise, exponential function to this number, right, we'll come to 1.111, which is, percentage, right? This. And of course, if I subtract 1, that's just the net return. And the same thing, right? As the last verification, let's try this. Common log of well, I can do I can do this simply by but let me do it this way. Common log of oops. I have to do common log of this. It's not dollars, it's a stupid thing because the formatting was already in dollars. Let me go to format dollars percent, right? I get exactly the same percentage, right? Or I can do, I should have done it there, right? Let me do it here. I would rather simply do, because this is log of, PT, right? Minus log of PT minus 1. Of course, I will get, oops, I was pointing to something. Okay, I get exactly the same thing, right? Get exactly the same thing, right? Many decimals, let me increase decimal. And here, I will do, okay, I will enter make that a subscript, and also this one a subscript. Okay, so this is the connection between APR and APY or EAR, effective, annual rate, and continuously compounded rate. Okay, and you can try out different numbers. I was originally trying out different numbers here, but the uh, capturing the growth rate by the quotient rule of log works only for a small change, like uh, 10% change, or you know less than 50%. If the change is like more than 100%, 200%, log the difference in the logs doesn't capture it well. For large change, Okay, so that's it for now. That's it now, and I will see you guys in the next video. Stop recording.